to Programming for Fun with Scratch, Episode 1. My name is Deeth Elza. I'm a Digital Services Technician with the Richmond Public Library, and we will be, throughout this series of videos, we will be looking at programming Scratch and answering some questions about it, and looking at some of the things that are kind of tricky in Scratch. So first of all, what is Scratch? So Scratch is a programming environment where you can snap together bits of code like Legos. It's called visual programming, and it is designed for children to learn to make their own games and animations and storytelling and whatever they can imagine. It's fun for all ages, but it is specifically designed for kids. We will look at how to use Scratch. Will be every week or every episode we will make a game. We will answer any questions that have come up, and we will look at one kind of hard challenge that stumps people in Scratch sometimes. And today we will be making Pong. Pong is one of the oldest computer games, and it is this page describes Pong. Pong is it's basically like ping pong or tennis. You have two players, each player has a paddle, and there's a ball going back and forth between them, and you just have to hit the ball so it doesn't go past you, and in which case your opponent scores. So it's pretty simple. There have been many versions of it made, and today we're going to make yet another version of Pong. So that's the plan for today. So this is the Scratch website, which is where we'll be working today. All of the Scratch work happens on their website, and I do recommend, if you haven't already joined Scratch to create a login, that you go ahead and do that. The advantage to doing that is all your work will automatically be saved, and you can also share it with your friends. They can see it and comment on it. You can see and comment on theirs, but mainly you can create things on Scratch and it will automatically save it for you. So you don't have to worry about losing your work or having to save it to your computer or anything. And then if you are working at another computer, you can also log in from there and all of your work is right there. So it's really helpful. Two safety things. One is you do need an email to sign up. And so you may need your parents to help you with the sign up process. And the other thing is, don't use your name. Never use your name to sign up online generally. I recommend using 2 words to kind of describe yourself, like happy puppy or fast cheetah or something like that, rather than using your name. But go ahead and log into Scratch or create an account. I'm going to keep going. You can always pause. I'm going to be going faster through this than I would do in a in-person class, because with the video you can pause it anytime you need to. You can go back and watch bits again if you miss anything. So I'm going to keep going, but go ahead and create your account or log in, and then restart the video and keep watching. Once you have your account and you're logged in, then we're going to click the Create button here at the top. So that takes us into the Scratch editor, which is where most everything happens in Scratch. So the Scratch editor has several main areas. Over here on the right, where this cat is, that is our window for our program. And we can make that big to see just our program running, or we can make it small. And that's where our game is going to be. Below that is the Sprite choosing tool, and so Scratch is organized around sprites. A sprite is an image or group of images that can move, and in Scratch each sprite actually can contain its own code, which would be this tab, its own costumes, which is this tab, and lets us see that this sprite has 2 costumes, so we could actually write some code that flips between them quickly and it'll look like the cat is walking. And we can add costumes, we can draw our own, we can import files, but we're going to use some built-in ones today. And each sprite also can have its own sounds. This sound is meow. And we can use blocks to play those sounds in our code. So all of these things are organized per sprite. So as we add more sprites, they will each have their own code, their own costumes, and their own sounds. And we can add all of those to any sprite. In this pane, over on the left, we have all the blocks that are available to us for writing our program, for writing the code. And they're organized into several groups. So we've got motion blocks that move the sprite around. We've got looks blocks that can change how the sprite looks. We've got sound blocks for playing the sounds of the sprite. Event blocks, which are important because all of our scripts, all of our code is going to be triggered by certain events happening. And so the first and most important probably is going to be green flag clicked. So when green flag is clicked, we'll start our program. And that way, when we go over here and click that flag, that starts everything off. So we're gonna use that one a lot. There are control blocks that can make decisions in our game, like if this is true, then do this code. If this is true, then do this code, else do this other code. So there's wait for a second or repeat a certain number of times. Those are all types of controls. There are sensing blocks to let us tell something about what else is going on in the program. So we can ask a question from the user, or we can say, if this sprite is touching a specific color, for instance. And then we have these operation blocks that let us do basic math, choose random numbers, tell if one number is larger, smaller, or the same as another number. We can do logical operations here, and we can manipulate strings of characters or text down here. And we can create our own blocks. So this lets us create blocks that are variables. A variable is a way of giving some value a name so we can refer to it later. And we can even manipulate it some. And here we can actually make our own blocks. So we can give a name to a block and add some other blocks to it and use our block as if it was all of those other blocks. And we'll see that a lot in this game. Once you've gone through all that and familiarize yourself with it, there are even more things you can do, because you can add extensions to Scratch that let you do more things, or even interface it with like Lego robotics or microbits or other types of hardware. But you can play music and draw with a pen and lots of different things. Draw with a virtual pen. Just don't try and draw on your screen with a real pen. All right, so that's the quick introduction to Scratch. We're going to learn more by doing, so we're going to see a lot of these blocks in use during our game, and we're going to create now several sprites. So the first sprite we need is not the cat, and we can click on the trash can icon to get rid of the cat. If you go down here to the right, there are two blue buttons, and they each pop up a little menu. And the first button should say choose a sprite, or the left button, and the right button says choose a backdrop. So we're going to choose a sprite. We're going to go up here and choose the ball. So now we have a ball sprite. It has several costumes for different colored balls. You can use whatever you like. It even has a sound, a couple sounds. Boink and pop. So we've got some sounds, and it has a place for code, but it doesn't have any code yet. This is where most of our code is going to be. Our Pong game will be driven by the ball. But we need some other sprites as well. We're going to need paddles. So click down here again, and we can actually search. There's a paddle sprite. And I lost my mouse. There we go. Okay, there's a paddle sprite, and we're going to actually click on that paddle sprite, and we're going to say that's paddle 1. And then there's another thing here that says direction, and if you click on that, it has a little arrow, and you can drag that arrow around, or you can type in down here. We want direction 0. We want that sprite to be up and down because we're going to be playing Pong left to right. Now we're going to want another paddle, so if you right click on that, you can duplicate it. And so it already says paddle 2, conveniently enough. All right. Now we're going to need a goal. So we're going to need something on each side that when if the ball hits it, we know that the other player has scored. So there is a sprite called line, and we'll just use that. All right. So we want to do the same thing with the line and make its direction 0. You can either drag the arrow or type in, and then we're going to just drag that line all the way over, so it's kind of overlapping the edge here. There, just so we have this thin kind of border, so the ball hits that before it hits the wall. And now we're going to do the same thing here. We're going to right click, or actually first we'll rename it. So this is goal 1. And then if you right click on that and choose duplicate, we should have goal 2. And we'll do the same thing. We'll just position that off to the right as much as possible. There. Should be a thin red line. And when we write our code, we'll actually hide the lines. Make sure that our paddles are kind of in the right place. We will position precisely with code once we get going. Okay, so that is, actually, we're not going to position the paddles with code, so let's make sure they are in the right spots. And the main thing is we want that X to be, where are we? Oh, that's paddle 2, okay. So paddle 2, we want X to be 200, and paddle 1, we want X to be negative 200. X and the Y doesn't matter as much, but we can just set it to 0 for now. And this paddle also set Y to 0. And I think that's good. Yeah. Now we have our goals, we have our ball and our paddles. That's all the sprites we're going to need for the game, but we're going to, the white background is a little boring. So if you go to the other menu button down here that says choose a backdrop, go ahead and click on that. We'll find a nice background for the game. I like Neon Tunnel. You can pick whatever you like, but Neon Tunnel works for me. And so now we have a really nice looking game. It doesn't do anything yet, but it will very shortly. So most games are going to have multiple scenes, and what that means is there are different parts to the game. So you might be exploring outside and then enter a castle, and that could be a different scene. Or you go in one level in Mario to another level in Mario. Those would be separate scenes. But almost every game, even the simplest games like Pong, have at least 3 scenes. And those scenes are the intro, where it explains the game, what game you're playing and how to play it. And that may also link to a more in-depth tutorial or to different starting options. Like if it's a racing game, you might pick the track you race on and the car you use. There's also usually an end game or a game over screen that tells you who won, what the score was, and how to start again. So we're going to use backdrops from a lot of that. We're going to have a little bit of code, but most of it's going to be in the backdrops. And so let's see, we can get rid of the plain white backdrop. And then if you right click over here on the left pane on the backdrop we've got and choose duplicate, we're actually going to need 4 of them. And so here, the first one we can rename. How do we rename? Oh, there it is. So from Neon Tunnel to Playing. So that's going to be our basic one that is the actual game while we're playing. And then we're going to have Intro. And then player 1 wins. And player 2 wins. Okay. Now, the one other thing we're going to need to do is there are two types of images that are used on computers, and Scratch supports both of them. One is bitmap, where every pixel has a color, and the other is vector, where it actually just tells how to draw lines and what color to fill them with. So these backdrops are bitmaps, and we need them to be vectors. So if we go to each one, we can say convert to vector. Okay, and that will let us manipulate text more easily. So if you click here on the T, and we're going to want to pick a color, so white actually works pretty well on this background. So, and then we've got the T, so we can go in here. This is playing, so we don't need anything there. But on intro, we're going to say what game this is. This is Pong. And now when we click in here, we can choose the arrow, and now we can make it bigger and move it around. There, Pong. And then go back to the text tool, and we're going to give some instructions for playing. So, player 1, it will use the WS keys. And back to text. Player 2, up, down keys. And that's not going to fit on one line. So let's make it. Maybe it will. One more thing is press any key to start. Looks good. Let's just give these some breathing room. Oh, that's pretty good. Okay, so that's our intro screen. And then over here we want player 1 wins. Can we center text in Scratch? I don't think so. I'm just going to use some spaces to center that. Move this over here. That's pretty good. Go back to the text tool. We want to say, how do I get back to purple color? Press any key to restart. And we can actually just copy this. So you can either use the copy button here, or you can use Command or Control C, depending if you're on a Mac or a Windows, and then we'll paste in here. Again, you can use the paste button or the keyboard. And this Okay, then we just need to change player 1 to player 2. And we're done. Okay, so now we have all 4 backgrounds that we're going to need. So let's switch back over, A to the code tab, B to our sprites. So we're going to do the easy sprites first. Alright, so let's choose paddle 1. And we're going to go over here and go down to control. And we're going to want our, is it controls? No, sorry, events. We're going to want our favorite event, which is when green flag clicked. So go ahead and choose that and drag it out here. And so that's any code that we snap under here will run when they click the green flag to start the game. Go to the motion blocks now, and we're going to want go to, and if you drag go to XY, it should already say go to -200, 0, because we positioned our paddle there. If not, change it to say that. So it should say go to X, -200, Y, 0. Now why is X negative? So X is always a measure of our left to right in the game. So as X goes up, we're moving to the right. And as X goes down, we're moving to the left. So what we're saying here is that what are we saying here? Oh, negative. So, and 0, 0 in Scratch, not in all programming systems, but in Scratch, 0x and 0y is in the very center. So negative x goes this way, positive x goes this way. And if we were to drag this, we're going to see now that y is also negative. So positive y goes up, negative y goes down. Okay, so if we click that, if we click the green flag, even if we move that now, it's going to snap back into the right place at the beginning of the game. The next thing we need is how this sprite behaves during our game loop. And our game loop is where our games spend most of their time. It just loops over the same code over and over and over to check to see what's happening and to do the next thing. And so we're going to look in the controls, and there's a block here that says forever. Do you think it's really going to loop forever? No, it's going to loop until we tell it to do something else or we quit the game. There's no forever. But forever means until you're told to do something else, keep doing this over and over. Otherwise, if we wanted to do something just like 10 times or 100 times, we could use a repeat block. And any code that is inside this block would repeat that many times. The forever loop means as long as the game is running, keep doing this over and over. And you'll see that in a lot of types of programs, especially games, is you're going to have that kind of a loop. Okay, so what do we want to do in our repeat forever? Well, the paddles only have to do one thing. They have to listen for their control keys, and then they have to move in response. And so we're going to need an if-then. We're actually going to need 2 of those, 2 if-thens. Okay, and so what it's going to say is if my up key is pressed, move up. If my down key is pressed, move down. That's what we want it to do. So we're going to go to sensing to tell whether the key is pressed. So there's a block here that says key space pressed. We can just drop that in there, and we can right click on it and say duplicate and get another one for the other. So now we have if key space is pressed for both of them. That's not going to work because we're not going to use the space for moving our paddle. Do you remember what we said for paddle 1? It was back here in the backdrops. So in the intro it says paddle player 1 uses the W and S keys. So let's do that. So we want player 1, paddle 1 to use W to move up and S to move down. All right, now to move up and down, we're going to go to the move blocks, and we're going to say change y, because y is up and down, x is left and right. So change y by 10 to move up, and change y by -10 to move down. So hopefully that's going to do what we want. We're going to test it now and see. What's the difference between change y by and change y to? So if we know we definitely want to move y to 0 to center the paddle, we would say change y to 0. Change y by 10 means take wherever y is now, wherever the paddle is now, and change its y position by increasing it 10. So it will move it up. So let's go ahead, click the green arrow, or green flag, and press the W key. Does the paddle move up? And the S key should move it down. If yours isn't moving, make sure your code matches what I have here. Now we need one more piece. Right now you can go off the screen, and that makes it hard to hit the ball. So we're going to take this other move block that says if on edge bounce, and put it at the very end of our script. So make sure your code looks like mine. The ifs should not be nested inside of each other or anything else. They should be one after another. The change y by should be in the if, and the key pressed should be in the kind of angled shape within the if. And then if on edge bounce should be the last thing. Okay? So now when we click the green flag and press S, we don't go off the screen. So that's handy. Okay, that is that paddle. Now we're going to take a shortcut for doing our next paddle. So we're just going to grab this whole bunch of code and drag it over to paddle 2. And now when we switch to paddle 2, that code is already there. Now what needs to change between paddle 1 and paddle 2? So if we ran this code right now, it wouldn't work, because paddle 2 would be in the same place as paddle 1. It would go to -200, and it would use the W and S keys. We don't want that. So first thing, let's change it to 200 instead of -200. So go to X 200 Y 0. That's right. And then we want the up and down arrow keys for player 2. So up arrow, move up, and down arrow to move down. Let's test that out. Now we should be able to move up and down those keys. WS still moves the paddle 1, and up arrow, down arrow move paddle 2. And we can't move off the screen with either one. Excellent. That's all the code we need for our paddles. Let's look now at the code we need for our goals. So we go to goal 1. This is going to be even easier. So we still need our when green flag clicked. And we only need one other block, and that's going to be under looks. And there should be a block that says change color effect by some number, 25. And what we want to do is change the effect there to ghost. And so now if we click this, that is going to fade. Actually, we want not change by, but change to. So go ahead and switch that. So set color effect to. So we want set ghost effect to. What do you think is going to happen if we made this more than 25? So if we say 50. Okay, now it's really faded. If we make it 100. Now it's gone. So ghost makes a sprite transparent, progressively more transparent. So by making it 100, you can't see that red line anymore. But we know it's still there, and we'll be able to tell if the ball hits it in our code. And so that's all we have to do for that block. And now we just drag that code over to goal 2, and we don't even have to change anything because it's going to be the same. So now when we click our green flag, both of those goals vanish. But they're still there to tell if we run into them. All right, so now most of our code lies ahead of us in the ball. So we're in the ball now, and we're going to also have a when green flag clicked to start everything off. So go to events, green flag clicked, and so we're going to then go to looks, and we want to make sure we switch the background to intro. So the first thing we want to show is how to play the game, and the ball is going to be in the way of that. So let's go ahead and make the ball hidden. So where it says show above the ball, you can click that, close the eyeball with a line through it, and it'll hide the ball. We will do that in code further on, but just for now, we can make sure it always starts that way. Okay, so switch the background to intro, and then we want to go to controls and wait until. What do we want to wait for? So it says press any key to start. So let's see, we had sensing, there was that space key pressed, but what about any key? Yes. So you won't find the any key on your keyboard. It just means you can type whatever key you want. And then the next step is to play. Now there's not a play block yet. But we're going to make one. So we're going to make a block, and we're just going to call it play. We don't need to add any of these things. So now we have define play, which is what it'll do when we run our block, and we have this play block. And that is our starting point. So when you click the green flag, it switches us to our intro scene and then waits for the button to be pressed and then switches to our play scene. And we will define all of our scenes like this with custom blocks. And we're going to make a few other blocks too. So the first thing that play does is initialize. So it sets make sure all the values are at some good starting state. Initialize. So we're going to create a block for that. And then we have define, initialize, and we have an initialize block. And then the next thing we're going to do is enter our game loop. And so that is under controls again. We're going to choose forever, just like we did for the other, for the paddles. And this is where our main loop of the game will be. And so we're going to need to move some amount. Every time we go through this loop, we'll move a little bit, move the ball. Then we're going to possibly bounce on the paddles. And so let's make a block for that. So it's only going to bounce if it's actually hitting the paddles, so we're going to call it bounce, question mark. So if there's a paddle, we'll bounce. If not, we won't. And so we have a way to define that, and we have a way to use that. So there's our second part of our game loop. We also, if the player hits the goal, we want to score. So let's make a block for that. Again, they may not be hitting the goal at any given time, so we're going to say score with a question mark. So if they are touching a goal, we want to score, and then we can put that in there. So we've got move, possibly bounce, possibly score, and just like with the paddles, we don't want to go off the screen, so we will say, let's see, nope, need move, if on edge, bounce. And that is our entire game loop. Now, this won't actually do anything yet. Well, it actually will. it'll move and bounce. So let's, oh, but initialize, we need at least one thing in initialize for this to do anything. And that is show. Okay, now, okay, what's going wrong? So we go here. Oh, we haven't hit a button. There. So it's not hitting the paddles yet, because we haven't written that code. And it's not scoring, because we haven't written that code. But it is bouncing. It's using this if on edge bounce. So it's just moving 10. So we're going to set up some initialization so it gets a little more interesting. So we want to make our initialize do a little bit more. And the first thing is also here under looks, we want to switch the backdrop to playing. And we want to reset the position. Now we don't have a block to reset the position yet. So let's make a, not a variable, but a block called reset position. And we can define that later. But we can already start using it. So let's put that there. And once we've got all of that, we need to initialize our variables, which are values we're going to use throughout the code. So let's go ahead and make some variables. So the first one we want is speed. So speed is going to be how fast the ball moves. And you have a couple options here for all sprites or for this sprite only. And we want our variables to all be for this sprite only. There's also cloud variables that are stored on the server. We don't need those, but you could use that to share high scores between a game, for instance. Okay, so now we have a speed. Now we're going to make, we need a, we need, is the game over? And so if it's 0, the game is not over. If it's 1, the game is over. We need a score for player 1. And this one, these player 1 and player 2 we're actually going to show. So go ahead and make that capitalized and write it out nicely. So player 1, player, I can't spell, player 2, did I? Oh, that's interesting. I guess it doesn't matter if they're, I don't want them displayed quite like that. So let's delete player 2. So I guess for our game it doesn't matter whether they are for all sprites or just this sprite, but when they're displayed in the game, it changes how they look. So whether they're displayed in the game is this checkbox over here. So game over does not need to be displayed. Speed does not need to be displayed. Just player 1 and player 2. And so we want player 1's score to be there. And I guess it doesn't matter how we display it anyways, because it's we can change it. All right, and player 2 here. And if you left click on that, you can choose large readout, and it's just the number. Just position that somewhere over here so that they are readable. So that's going to be where we show the player the score, and we just do it by changing that variable. Okay, so now we need to initialize them to some default state so that they are where we want them. So in our initialize code, we're going to say set game over to 0, which is correct. And we're going to bring another set, and we'll change the game over to player 1, also 0. And player 2, also 0. And then speed, we'll start off at 10, but this will give us the ability to change the speed. So, for instance, every time the ball gets hit by a paddle, we can make it go a little faster, and that'll make the game a little more challenging. So while we're here, let's go ahead and grab speed and drag that into our move. So now we're still moving the same speed. That hasn't changed the game any. All we've done now is all of these values are reset when we click the green flag, and when we hit any key, it's going to still doing the same, still moving the same speed, but now we have a little more control over it. And we have these other values that we can play around with to communicate between different parts of our game. Okay, I forgot one more variable that we're going to need, and that is who scored last. And we're going to use that for determining who serves the next ball, so which direction the ball goes in. And so we're going to actually, that's going to be a little more complicated to initialize. Let's drag that over to our initialize block. So initialize scored last. It's going to be 1 or 2, and we will set it whenever somebody scores. So if player 1 scores, we'll set it to 1. If player 2 scores, we'll set it to 2. But in this very first round, we don't know who scored in the last game or even if they've played before. So we'll just pick one at random. And we have a very cool operator for that. I'll pick random. So drop that into our set block. So set scored text to pick random 1 to 2. So it'll pick either 1 or 2, and it could be different every game. We don't know. Okay, that's great. Now let's go ahead and define our bounce block. So right now we're calling bounce down here, bounce, question mark, but it doesn't do anything. So let's make it do something. So what do we want it to do? So bounce is going to first mainly say, are we hitting a paddle? And so that's going to be under controls. We're going to want if, and then we need a condition. And the condition is going to go in this grayed out angled space. So conditions are we're going to want them sharing. So here we have touching mouse pointer, which is a drop down. So if touching mouse pointer, then, but let's change mouse pointer to paddle 1. So if touching paddle 1, then bounce, and we don't have a bounce block yet. So let's make a bounce block. So that is under my blocks. Make a block that just says bounce, because both of the regardless of which paddle we hit, bouncing will be the same because of the way it's coded. And so now we've got a bounce block. Say if touching paddle 1, bounce, and we can stack all these blocks together again, or we can say duplicate, put it afterwards, and we just need to change if touching paddle 2, also bounce. All right, so what do we do when we bounce? Well, that's a good question. So what do we need to do when we hit a paddle? We need to change direction, but not reverse direction, because if we're coming in from an angle here, we don't want to bounce back at that same angle. We want to bounce off and keep going at like a mirror image of that angle. And we want to, we've got this speed variable, so every time a player successfully hits the ball, they can make it go a little bit faster, so we want to increase the speed. And we also, because of the way Scratch works, and each step we're moving several pixels, we can actually get a sprite stuck in the paddle, so every time through the loop it says, oh, it's still touching the paddle, bounce, and then it moves back, but it's still touching, so it bounces and it moves back, so it just vibrates back and forth. So we're going to get around that by just doing an extra move when we hit the paddle. And then we'll make a sound, because that'll make it more interesting. So let's do that. So the first thing we said was we're going to change the speed. So that's going to be under variables. And so we've got set that we've been using, but now we want change. We just want to take the existing speed and add 1 to it. So under define bounce, and say change speed by 1. That'll add 1 to whatever the speed currently is. And then we want to change the direction that the ball is going in. And to do that, oh, it's going faster and faster. Let's stop that now. That's getting annoying. Okay, so there is a direction variable already. So we don't need to have like change direction by, but we're going to do the same basic thing. So we want to set the direction. Where is it? Point and direction. And we need some math. So that would be under operators. We want minus. Now there are 360 degrees in a circle, and that's how the directions work. But the way to get that kind of mirrored bounce, what we can do is 0 minus the current direction. And we should get a good bounce, at least as long as we're working left to right. I think it would be a little different if we went up and down. All right, so now we are changing the speed. We are changing the direction that we're bouncing off of, and we need to move so that we don't end up getting stuck on the paddles. That's going to be under motion. Move, speed blocks. Speed is down here, under variables, move speed steps. And then the last thing we said was to play a sound. So let's go here under sound and say start sound. If we chose the first one, play sound until done, the ball would freeze while it's playing the sound. So we don't want that. We want to start the sound. Let's say this pop or boing. That's a nice bounce sound. We'll go with start sound pop. Okay, that's our bounce. So now we go here, press a key. We should bounce off the paddle with a little popping sound. And the way we're doing it, where we have this extra move, it prevents us from getting stuck, but it also looks like the ball isn't quite touching the paddles, but that's all right. And now one thing we didn't do, we kind of skipped over, was reset position. So let's take a look at that next. And the reason I want to implement reset position now is because part of what we're going to do is set the direction of the ball, and it's going to make bouncing a lot more interesting. So let's do that. So when we start the game, we first want the ball to go back to the center. So we want a go to XY here, and we'll change both those values to 0. That's the center, 0, 0. 0 and X, 0 and Y. So remember, X is left to right, Y is up to down, and 0, 0 is at the very center of that. We're also going to reset the speed. So every time we reset the position, we set the speed back down to 10, so it doesn't just keep getting faster and faster and faster and faster. So that is under variables, set speed to, set speed to 10. That's our base speed. And then we need a control block. So this is where we get to use one of our variables that scored last. This is where that comes into play. So we want an if-else block. So if condition, then do these blocks, else do these blocks. So if what's in here is true, it'll do the blocks that are in here. If it's false, it'll do these blocks. It's a decision-making tool. Okay, so we want to point the ball in a direction. So even though the ball is round, it can turn, and it just like we turned the paddles, it has a direction. And as you can see here, if we go here, like 45 is, where is it? 45 is right about there. And then if we go the same direction, the same amount in the other direction to 135, then that's actually a pretty good range to be serving a ball towards player 2. And the same thing here, we can do negative 45 to negative 135, and it's going to be, whenever we say move, it's going to move in the direction it's pointing. So that's actually a good way to send to player 1. So let's do that. So whoever scored last, we're going to let the other player serve. Whoever got scored against is going to get to serve the next ball. So if last scored, that's what we want. If, so we need an operator here. We need equals. Equals. If, and then our variable last scored. Where is it? Scored last, sorry. If scored last is 1, then we want the ball to point in a direction. That's under motion. Point in direction. And we want to choose a random number between those values. So we're going to pick random, put that in there. So point in direction, pick random. And what did we say? 45 to 135. And now if we right click on that point in direction, we can say duplicate and drag it down here. And we just need to make those both negative. Negative 40, actually we should probably flip them too. So negative 135, because negative 135 is less than negative 45 if you look at the number line. Negative 45. Okay, so now when we click this and hit a button, now we're not just bouncing back and forth, but we're going in a different random direction each time. Now we're still not quite there. We're not serving, or we're not scoring. So let's take a look at building that. All right, we want to implement the score, and this is one of the more complex bits, I think, but nothing too bad. We're going to take it step by step. So we're going to need an if block. And so how do we know if we've scored? Well, we hit one of these goals, right? So if, where would touching be? That's under sensing here. So we're going to say if touching mouse pointer, and then we'll just change mouse pointer to goal 1. And what happens if we touch goal 1? Who scores? So if the ball comes over here and touches this goal, it's because player 1 missed. So player 2 scores. So we want to say score for player 2. Now, there's no score for player block, so we're going to go back over here to my blocks and make a block and say score for player. And now we actually want to add a number here. So we want to say 1 or 2 for the player. So let's add an input and say player is the name of that. And now we're going to say okay. Actually, I think I don't need the space there. Here. Okay, that's good. Okay, so now we can define score for player. We'll do that next. But now we can use that. So we said if it touches ball touches goal 1, score for player 2. And we're going to duplicate all of this. Remember, right click to choose duplicate. And now if touching goal 2, score for player 1. And that is our score question mark. So now we definitely have hit a goal, and we are going to score for one of the players. Now, why did we use 2 if blocks instead of an if else? If we used an if-else here, the block would be a little bit shorter, but it would be totally wrong, because we would say if touching goal 1, score, that'd be right, else, well, most of the time it's not touching either of them. So the else would fire all the time when the ball was traveling around the middle. Player 1 would be racking up points, which would be great for player 1, but player 2 would be getting kind of the bad deal there. So we want an if block followed by another if block. And then what happens if neither of them are triggered, because we're not touching either post? Well, just like if we're not touching either paddle, nothing happens. We just fall right through, and this define is the same as when it was empty, for the case where it's not touching either of the things we're asking about. So I hope that makes sense, that we're saying, you know, in this score question mark, we're saying if we're touching the goal, score. If we're touching the other goal, score. Otherwise, don't do anything. And that's what this whole empty this here is that's the, for otherwise don't do anything, else nothing. So I hope that's clear. So score for player, we're going to need to make a decision first. Which player is it? And so this is where we will use an if-else block, because we know it's one or the other. We already know we're scoring. That's what we figured out here. So there's no question mark about this. We're scoring for one player or the other. So we want to know which player, and that's going to be an operation of equals. So if player is equal to 1, and then otherwise, yeah, so we want to change the score, right? That makes sense. So under variables, we've got change score by, or change by. So if player, if we're scoring for player 1, change player 1 score by 1, and we can duplicate that, drag it down here, and make it change player 2. All right, so we are scoring one player or the other. If player equal to 1, change player 1 by 1, and that'll show it up here. Otherwise, player 2, and again, that will show up here. You can see if I click on that, then it goes up. All right, so what else do we need to do when we score, though? There's more to it than just changing the scores. We need to say who was the last player to score, because that's going to change, where is it? Our initialize does it, but then, reset position, based on who scored last, right? So when we serve again, which is going to happen right after we score, we need to know who the last player that scored was. And so let's go ahead and set that. Scored last is equal to player. So we just grab player. We get a player argument here. So we passed it. We say score for player. We say 2 or 1. Well, that 2 or 1 is now in this player block, and we're dragging it here. So we drag it here. If it's 1, then we do this. Otherwise, we do that. And here we're setting scored last to whatever was passed in over here. So again, I hope that's clear. Feel free to ask questions. In the description of this, there's a link to a form where you can ask us questions, and I'll answer that in the next episode. What else do we need to do? We need to, let's play a sound. We scored. That should be worth something. So sound. So again, we're going to start sound. We already used pop. Let's use boing. It's an okay sound for scoring, I think. We also need now to serve, right? So the ball has hit our goal. We need it back in play. So we already have a block for that, conveniently enough, and that is called reset position. We can reuse these blocks that we've made in more than one place. So we used it in initialize, but now we can use it over again here in score for player. We also need to see, as the score goes up, did anybody win? So, right, I've been writing Pong that goes up to 3 points. You can make it whatever you want, but at some point, somebody should have enough points that they win. And so we want to use the game over block, and there is no game over block, right? So let's make a game over block. Game over question mark, because we're just checking to see if it's over. So we've got now, we can define our game over, and we can use a game over. So here, game over. So now, score for player actually sets the player's score, bumps it up. We're already displaying it automatically up here. We set scored last, so we know which direction to serve in. We play a sound. We reset the position, which is basically serving, and we check to see if the game's over. So all that is good. And now we need to define game over. So the game over, we need to check to see if either player has won. So we're going to need a couple of if blocks. And you'll see all of our question mark ones generally start with some if blocks to check conditions. And then we can move on to, yes, this definitely happened. So bounce, we check to see if we're touching a paddle. If so, we call bounce. Now in bounce, we know we are for sure bouncing. Same thing with score. We check to see if we're touching a goal or not. If so, we are definitely scoring, so we go to that block. And here, game over, we're not sure yet. If the score is high enough, yes, the game is over. So, it's a pattern you'll see come up a lot. All right, so what do we need to check? We need to see if the value of the player's score is higher than what we've said is for winning. So we're going to want greater than. So we need 2 of those. We'll just grab them both. We could use duplicate. Doesn't matter. I'm going to say 3. Makes for a nice quick game. You can make it a different number as long as it's consistent. All right, so we need player 1 and player 2. All right, so if player 1, which is this value up here, if it's greater than 2, so meaning 3 or higher, but I said it greater than 3. 2, well, we'll make these 2 if we're playing to 3 points. We could say equals if something happened in the game where you managed to score really fast, then we could end up with a score of 4 and keep going forever. I like using greater than for that. So any number over 2 is going to win. That number is going to be 3. But if something went really wrong and it somehow got to 4, it would still be game over. Player 1 is greater than 2. We want to set game over to 1. So yes, game is over. And we want that in both places. All right. So I right-clicked and duplicated. That's if I'm going too fast, that's what I did. And we need to call the final stage. So we have the intro stage, the playing stage, and game over stage. And I said earlier we're going to have 2 game over stages, 1 for each player. And each stage basically has its own block. So let's make those blocks. So player 1 wins. I lost my mouse. There it is. Okay. And player 2, player 3, there's no player 3, wins. Okay. So we've got those. And we've got them here. Player 1 wins if we're defining game, yeah, right here. So we set game over to 1, player 1 wins, and set game over to 1, player 2 wins. That's all we need for game over. Now, when a player wins, what do we have to do? Well, we're going to go up here to looks, and we are going to switch the backdrop to that player. So if player 2 wins, switch to player 2 wins. If player 1 wins, switch to player 1 wins. We also, if you remember those backdrops, we want to be able to read them. So let's hide the ball. Also under looks, so hide, we'll put that into both of them. And now we're in this scene, and we need a way to get back to the play scene. So we're going to do that the same as we did in the very first, in the intro scene. We're going to say, it's under controls, I think. Wait until. Wait until. And we want a key pressed. Which key? Any, no, not touching. Oops. Key. Any key is pressed. And we could have it, triggered by mouse click if we wanted, but this is fine. And then we'll go back down to my blocks, and we're going to go back into the play scene when they press a key. So we're just going to start it all over again. All right, let's give this a shot. So put your fingers on the W and S keys, and get ready to put your other fingers on the arrow keys when you hit the green flag. So now you press any key to start. It should get faster and harder. I'm going to just go ahead and make sure that I'm getting scores right. Okay, yeah, I'm scoring in the right direction and serving, I think, in the right direction, right? So if it goes off that way, well, it wins. Oh, no, it's serving the wrong way. So it should be when the ball goes off to the left, it gets served to the right. So let's just fix that. So all we really have to do is switch these. So point and direction. Let's try it now. Green flag, hit a key. I'm going to intentionally lose. Yeah. Now when it goes off to the right, it gets served to the left. Excellent. And now, player 2 won. It says player 2 wins. Press any key. We have a complete game. Now there's more you could do. You could have when another sound that when somebody wins, there's a cheer that goes up, or you could have the paddles shrink each time somebody misses to make it even harder. There's all sorts of things you can do, but you have a working game here, and I will put a link to this game. I'll share it. And I'll make it public. What is Pong is the name, and I will share it so that it can be seen. And I'll put a link to this in the description below. So if you have any ideas, if you make it more interesting in some way, if you have any problems, let me know. Again, the link in the description takes you to a form you can give us feedback at. And you can also, when you're logged into Scratch, you could go to my project and copy it and make your own version from that. Or you can look at my code to get the, if you've missed anything in the video. So you can definitely use my version to make your own, or you can use my version to help you. If I went too fast anywhere, you can go see exactly what blocks I used where and how my code works. So feel free to do that, and I will paste that into the description. And now we're going to take a quick look at some common problems in Scratch. Mainly today we're going to look at jumping. I've got 3 examples here of, well, I've got 4 examples in this project and then 2 other projects that show how to do jumping in Scratch. The reason jumping can be tricky is because it happens over time. It's not like you can just use a jump block and be done. You have to kind of say what else happens around it. And it can be, there's easier ways and harder ways. And the other thing is that you might even want to change what the sprite looks like at different points in the jump. So this example, this project, each of these ballerinas has a different jump implementation. So you can, if you go into the project, and the links to all 3 of these projects will be in the description. So if I go in and you can press Z, X, C, V, which are all next to each other on the keyboard, and you'll see Z jumps, X, C, and V, and they all look pretty close to each other, but they're all implemented differently. And so let's look at the pink princess here on the left. All of them start the same. It sets a position to move to. It sets, in this case, this princess has a, or this ballerina has a velocity. That's how it's implemented. Velocity is the rate that their speed is changing over time. So, and they all are going to have these switch costumes at different points. So this is Ballerina Sprite comes from Scratch, and it has several costumes already. So it has these nice kind of jumping costumes, so it's very useful for this project. And then I have a forever loop which just listens. Well, basically it's going to change the y value by velocity, and then it's going to change the velocity value by -1. And what that means is velocity is going to continually be moving the ballerina faster and faster down. So basically she's always going to be falling faster and faster but if she's touching the line, and you can see the line, just like in the last project, we could make the line invisible and still be touching it. But I wanted you to see the line. If she's touching the line, and if the key Z is pressed, then we switch her costume and change velocity to 15. Now, if velocity is positive, she's going to go up, but each time through the loop, velocity is going to get decreased, so it'll be 14, then 13. So she's going to go up slower and slower, and then stop, and then start falling back down. And then, so if she's touching the line still, if key Z is not pressed, that's the else part, we switch her back to Ballerina A and set velocity to 0, so she's not falling or rising. And then if velocity y is exactly equal to -1, then switch her costume to Ballerina B and wait for 0.2 seconds. And so that is just at the very top of the arc. When she just starts falling, then we switch to the falling costume and kind of pause just briefly there at the very top of the arc. And let's see that. She rises faster, rises fast, and then slows down, stops, changes costume, and falls. It's a little complicated, a little messy. Let's look at Ballerina 2. Now I'm going to press the X. She's going to go up and down. And it looks a little different. I've pressed them at the same time. They don't quite match. And that's because they are using very different systems. So Ballerina 2 doesn't have any of that velocity thing. So all of the ballerinas except the first one have a set color effect, just so you can tell them apart. The color effect just cycles through the colors. So, and they all have the same switch costumes, although how we get to each costume is a little different because of everything around it, all the code around. But what do we do here? So We've positioned her, set her color, switch costumes. That's just the basics. Now we have a forever loop. If she's touching the line and key X is pressed, then switch costume to jumping. Glide for 0.5 seconds to the same position X, but the current Y position plus 100. So glide up 100 pixels. Then switch costume to falling, or to hover it up there. What's Ballerina be? Ballerina. So that. So there's this jump there. So C and then falling back down. Okay, so switch costume to Ballerina C. That's what's used for jumping, and then at the very top of the jump, and then falling back down. Okay, so switch to the jumping costume, glide for half a second up to that position, up 100 pixels, wait 0.2 seconds. So again, we kind of hover at the very top, switch costume to falling, glide back down for another half second, and 100 pixels, and then switch to costume standing again. So let's look at that. So the difference here is the first one is going to be more, I guess, realistic. It's how jumping and falling kind of works in the real world. When you jump, you start off fast and slow down as gravity takes hold, and then pulls you back down, and you fall faster and faster. So that's the first ballerina. The second ballerina just glides up, glides down at the same rate, but it's a lot easier to understand the code. Now with Ballerina 2, you kind of have to know where she's going a little bit. And we just said, she's standing in place, keep the same X and make Y go up, but the glide, you have to tell it where you're gliding to and where you're gliding from. Whereas the Ballerina 1, if she was moving, but she still jumped this way, it would still work, as long as we know where to stop, which is, in this case, when we hit that line. It could be when she gets to a certain X value or Y value. Could be, you could have different conditions. We're using the line for now so that they all kind of work the same. All right, so let's look at Ballerina number 3. So Ballerina number 3, we've got the go to position and color effect and switch to Ballerina a costume. And then again, we've got a forever loop. If touching the line and key C is pressed, then switch to jumping, costume, and repeat 10 times. Change Y value by 10. And each time wait 0.1 seconds. So that's what that looks like. A little jerky. If we just changed Y by 100 to move up, it would be instant. That should just be at the top and there wouldn't be any sense of motion. So even if we just loop through changing Y by 10 and by 10 by 10, it would be like if we just made this 0, right, then she's just gonna go straight up basically. Is that right? Actually, that's not so bad. Maybe we don't need that. Anyways. She goes up, switches to costume where she's falling, waits 0.2 seconds, kind of hovered at the top of and then falls down. Switch, I guess that's a hover ballerina, and then that's the falling. Again, we just change Y over and over. So here we are just changing the Y value 10 times as she goes up and 10 times as she goes down. That's basically what that is. And then for Ballerina 4, now she's rotated here. And the reason for that is if you use what we did with the ball, where you just say move, it's going to move in the direction she's facing. And she was, in this position, she was facing to the right. We've got her rotated here, but that also, then in code, we rotate her to be standing up. And what that does, and also I think here, what that does is makes her facing this direction, because otherwise she would be facing over here, and she would jump to the right and then back to the left. We've rotated her sprite. We actually in costumes, we went and rotated the costume, and then we can use move. But as you'll see, move her into position, set her color effect, switch her costume. All that's the same. We have a forever if touching line, and key V pressed, jump. Okay. The only difference between Ballerina 3 and 4, besides the fact that 4 is rotated, is we're using a move 10 steps instead of change Y by 10. And then move by negative 10 steps instead of change Y by negative 10. That is really the only difference between these two, is just whether we're using the move block or change Y by block. This one is different, that we're using the glide block. And this one, we're actually doing a really tiny physics emulator and building in gravity so that she jumps and falls with a super simplistic physics engine. So that is 4 different ways to jump. Now, real quick, I'm going to look at this jumping princess example. And so I have a slider for how much she jumps by, and she has to jump over these 2 wraiths. I'm going to make that big so you can see what's going on. So she can jump, and so she's moving kind of diagonally here, and jump. Oh, she hit the wraith. How do I restart? Oh yeah. Okay, so jump. She hit the wraith. So this is hard. No, it's not supposed to be that hard. There. I hit the second. Now we can make it easier by making her jump higher. So, oops. So, what's going on here? Okay. There. Done. So let's look at the code for that. So she has a speed to jump up, whether she's jumping, a jump amount, and whether the game's over as variables. So as long as the game is not over, and if the right arrow is pressed, then move to the right and move up and down a little bit. That's how she moves diagonally. And if the left arrow is pressed, change, the same thing. She's moving diagonally. If not jumping and the space key is pressed, then you're going to set her speed up to jump amount and set jumping to 1. So that jump amount is this. That's how we can vary how high she jumps. But basically, you're going to give her a speed moving up based on whatever the slider is at, and set jumping to be true. And then if she's not, so if this block isn't true, then, and she's jumping, change her Y by the amount of speed up, and then change speed up by -1. So this is like the Ballerina with the physics engine. A little bit more complicated because we have a slider here to change how high how fast she jumps and things like that. But this is very much the same as that that first Ballerina here. It's the same idea of building a little physics engine so she jumps up and slows down and then falls until she hits the ground. We just have to have some way of knowing where the ground is, like where to stop falling. And then we just have the ghouls and whether they touch her to end the game. All right, so that's the jumping princess example. This is a platformer example, and so we're going to, let's start the game. So we've got this little frog wizard, and we can jump with the up arrow and jump onto the platforms, And when he hits the gold, he goes to the next level. If he hits red, then bad things happen. He has to start the level over. And it gets tricky. Yeah. So anyways, that's, I'm not going to step through all of this because it's a bigger example. I am going to show just a couple of details. So if I go over here to the backdrops, you can see that everything about the level is encoded in the backdrop. So we can just, if we want to add more levels, we can just draw more backdrops, as long as they don't have green, red, or yellow in it. That can be tricky because we're just using if touching color to say what happens. So if touching green, stop falling, basically. Again, this is using something like a physics engine. The frog is basically always falling, but when you jump up, it falls by a negative amount that then grows, and so it falls back down, and when it hits green, it stops falling. If it hits gold, it changes the backdrop and repositions up in the upper left, and if it hits red, it starts the level over again. So it's a really simple way of making a platformer. There are other things you can do that get more complicated, where you have sprites for the platforms and things. But if you want to get started with a platformer, this is a good project to work from, because you can just draw a bunch of backgrounds and have something working very quickly. So again, links to these projects will be in the description. Go ahead and play around with them. Feel free to make your own versions of them. You can always send links to your versions in the feedback form, and I would love to see what you've done. Being the first episode, there aren't any questions to answer, but do feel free to send me your questions about Scratch. If you're having any problems, or if you have something you've wanted to try with it, or an idea for a game, or something that you'd like to do but you aren't sure how to get started or are stuck somewhere, send me links to your projects, send me your questions, and I'd be more than happy to address those in future episodes. And glad you were here, and I hope you've enjoyed this. That's all I've got for today, so I will see you in the next episode.